Welcome to the Debate at Go8 podcast series exploring the issues and research affecting the Group of 8 universities and, by extension, Australia's economy and our society. My name is Ron Candelars. I'm a freelance journalist and producer, and throughout this series we've been canvassing a range of topics touching upon the work of all the Group of 8 universities. They include the Australian National University, Monash University, UNSW Sydney, the Universities of Adelaide, Melbourne, Sydney, Queensland and Western Australia. Today we'll be exploring the amazing work done by Professor Salah Sukkarieh from the University of Sydney, a leader in robotics and intelligent systems. Professor Sukkarieh's groundbreaking research is changing the way we live and has huge ramifications for everything from global food supply to our understanding of the universe. Joining me for this podcast is the Go8 CEO Vicky Thompson, who, like me, has many questions about how Professor Sukkarieh's work in robotics and intelligent systems is changing our very notions of what we thought possible on our farms and on other planets. Firstly, Professor Sukkarieh, could you give us a potted history of how you got into this field and the nature of your work at Sydney University as Professor of Robotics and Intelligent Systems?
I did my PhD in navigation systems, which are the kind of like part of the essence of any robotic platform. So for a robot to kind of understand where it is and where it needs to go. That kind of took me on a venture in ground robotics, and we did some work with Patrick Stevedores around automating straddle carriers. These things move around in cargo terminals and move around autonomously. That led me into mining and drones and some work on rovers for space missions and just got me working more and more out in the environment, where I then interacted with farmers and we started going down the agriculture robotics path along the journey. So that was kind of the process. And I guess my work is very much focused on translatory research. So I like working on some of the strategic algorithms, but then seeing that all the way through to engagement with industry and kind of getting that challenge of how this technology may work in industry and the feedback from industry, which then drives a bit more of the research.
So just from that little potted history, it shows the vast array of projects you've been involved in and the impact of robotics more generally. I, Robot was a 2004 science fiction film starring Will Smith. It doesn't appear to be science fiction anymore.
Yeah, no, it's. I mean, I think the difference between some of the things that we see in movies is the level of AI, so level of artificial intelligence on board. So what you kind of see in those movies is quite a sophisticated, intelligent machine of some form. We're probably still a while away from that. But in terms of the capability, the physical capability, the way robots interact in the environment, yes, we're seeing a lot of that. It's explosive. It took a while right at the beginning. 20 years ago, you could run a project and it would take about 3 years before you demonstrated something of some interest. And now, 3 to 6 months, you can turn around some robotic platforms and demonstrate some significant capabilities in their environment. So it's speeding up, and the technology's helping that, as well as our understanding of how these platforms interact with the environment.
Because you've spent a lot of time dealing with advanced robotics for agriculture and world food production. Tell us about that. Why is it so important?
There's a number of reasons why. Agriculture productivity is in the decline. We've used a lot of the soil, the nutrients within the soil, so we're seeing drops in productivity there. So that calls for precision agriculture. We're using a lot more chemicals on farm, and there's a desire to reduce that, both from the industry as well as consumers. So there's a desire for precision agriculture there. And what we're also finding is that labour is on the decline, and it's not just a question of, say, Western countries, Australia, the US, UK, Europe. So we're seeing people there not wanting to work on farm, but also happening in developing countries where the younger generation is moving into the city. So there's a food security, nutrition security, environmental security issue. And what we found over the years is the ability to kind of use sensing, machine learning, AI, and also robotics can help pave the way to kind of maybe slow down the trend or even reverse it in some cases. And that's really where our focus has been on the research.
Could you give me an example of this sort of science rectifying problems of, I don't know, soil degradation potentially, this sort of robotics playing a greater role in ensuring that the soil produces more than it previously has?
So there's a couple of areas there. So when you work on farm, generally there's tasks that you want to do every single day, such as weeding and spraying. And if you use current tractor systems, you get a lot of soil compaction. Being able to work on mobile, smaller electric robotic platforms means that you can work on farm continuously with those robots and reduce the amount of soil compaction. Then the use of chemicals means that we can use machine learning techniques to identify the stage that a plant is at, its growth stage. We can determine whether it needs less or more fertilizer down to the individual plant, which means you're very precise in the type of chemicals that you use and how much of it you use, which then means you get less leaching into the soil, which is an important element as well. And when looking at things such as weeding, at the moment, current process is that you might spray some sort of weedicide to get rid of the weed. You blanket spray. You're trying to find chemicals that don't affect the crop that you're trying to grow. But with the technology, we've been able to do things like precision weeding without any chemicals, so using mechanical tools. So it's almost like chipping away at a weed, but doing it autonomously with the robot, which means no chemicals get used. And now we're starting to move into how you can do real-time soil analysis so that you can get a picture of what's going on below the ground as well as above the ground so that you can make more informed decisions. So collectively, that all comes together to help improve on that soil productivity and overall effectiveness of crop production.
We hear a lot, and you've mentioned, you like the fact that you are engaging with industry at the kind of the output end, and you've worked across many industries with navigation systems, mining, drones, and we've just talked about agriculture. One of the things that we hear a lot, Ron, when we're talking about university research and engagement is that industry doesn't understand universities and universities don't understand industry, and there's this great impasse. And a lot of effort has gone on at the sort of policy level, government level, to try and encourage universities in particular to engage with industry. And look, it is both ways, but there does seem to be a propensity to blame the universities for that lack of engagement, if you like. So I'm just really interested from your perspective, because you're doing such groundbreaking work in so many areas of absolute international need. You talked about food security, etc. How challenging is it for you to engage with industry? Who reaches into who?
And that's a good question, and I think it's a bit of both. I think when I first started out, it was probably a much harder position to be in earlier on for exactly the points that you mentioned there. In addition, maybe the way the university system worked earlier on, it wouldn't say it didn't encourage, but it didn't make it easier to kind of work with industry because of the way measures are, with academic scholarly measures as well as measures around promotions, all those things came together, and that just made it a little bit more difficult. I think it was more, it's just a general interest for me and a desire to want to see technology go out there. You just push through that. It's a lot easier now, I think. And I think what I personally found is that as you start to engage more, you start to understand the language better. You start to understand the differences in measures and metrics between what you want as an academic or as a university partner versus what they need. But you also find the common ground between it all.
But therein lies the great divide, isn't it? The sort of gap. And it's interesting because you're not the first person that we've spoken to on these podcasts from our universities who talk about the challenges within the structures within the university as being somewhat of a barrier to engagement. You talked about promotions and the different drivers about, the publish or perish line that we often hear about, versus industry, which is, they need something and they need it kind of in real time and they need it yesterday, because all of the work that you're doing, from what you've just described to us, is around improving productivity and improving the bottom line for a lot of, in this case, agriculture, farmers, etc. And so I just wonder, you really have a clash of cultures in a way between industry and universities, and it's probably more to your point about the relationship building that you've done to make it a bit easier. Would you characterise it like that?
As a researcher, you need to understand the temporal differences, I think. So you still want to do strategic fundamental research. You still want to do applied research, and you'd like them to fund it for you. And in that process of doing that, you also need to understand that there's an impact for them that needs to be done in a much shorter time frame. So when you're structuring your research program, you're thinking through all those temporal relationships from strategic research all the way through to the engagement. And in thinking of that temporal, you've got to get an understanding of their business metrics as well as your own metrics, and getting the wording right, getting an understanding of how you demonstrate how your research feeds into their business metrics is all part of the process that you go through. And it is it's a process that doesn't happen overnight. If I knocked on a new industry partner's door tomorrow, it could be 2 to 3 years before I get an industry contract, but it takes that time to build up that rapport and that understanding, and defining being able to define the problems and solutions properly that you both agree to.
And that was very obvious in the video that I saw that was run on Catalyst on the ABC of the swag bot. And you could see you out in the field with the farmer. It's a little motorised device that takes hay out to a property. And I suppose that's one of the menial sort of relentless tasks that has to be done. And you had to ensure that the cows weren't spooked for a start, that it could cover the terrain that it needed to. And that required a lot of toing and froing between you and the farmer. And that's the sort of engagement you really need to nut these things out, don't you?
Yeah, I mean, the agriculture is a classic scenario where your funding body is not necessarily the end user, and also may not exactly know the specifics about what happens on farm and in the operation. So we might get funding from, in this particular case, say, Meat and Livestock Australia, so they're the levy partners. But the farmer is the one that you want to engage with on that daily basis, because it's those little things that happen on farm that completely can change the way you might do your research. You know, when we first implemented that robot swagbot, you know, one of the things they said was, can you herd the animals, right? Because that would be great. Because if you can herd the animals to better pasture, then you make, you know, life easier for everyone, and the animals would be healthier. And so we did the classic approach. You know, what do you do now with your dogs? Okay, this is what you do. Okay, great. We're going to put the same behavior in the robot, and off we go. We're going to start pushing these animals around. But the moment this robot gets within 50, 100 meters, it completely changes. The animals start running away, and so just discussions with the farmer. Well, you know, if the robot spends a bit more time with me as a farmer, then I might get used to the robot, just like they get used to the dogs and the ute. So okay, so we'll do that. We'll kind of have the bot kind of move around with the farmer, and lo and behold, that's what they did. Once the robot got used to it, we realised that to move animals from one paddock to another didn't require you to herd them as the dogs do. You actually took on a Pied Piper approach, which was, you know, they got used to the robot. So put a hay bale at the back and just move the robot around. The animals will follow, and that changes your algorithms. It changes the way you write the software. It changes the way you might put the sensors on. So it changes completely how you might approach the research, just because of that one little element that comes up from the from what the farmer tells you.
And what was the reaction of farmers like? Do they think, you know, what's this bloke from the uni doing here with his robot thing? You know, like, is there a certain pushback to begin with?
When I first got involved in this, which was probably 2010, I was invited to give a talk at an agriculture industry conference to talk about robotics in general. And I remember that meeting where it was like complete disbelief that robots would ever work on farm. And again, you're coming from a university, so what would you know about what happens on farm? But I think the classic thing, just kind of going back to that industry research relationship, is there's always a champion somewhere in industry. There's always a couple of people out there that really do see the benefit of the research and where it can go. And you have that, they're the ones that you hook onto. They could be industry representative, or they could be within a company, but they're the ones that you want to work with, because they're the ones that are going to push the business case through management inside industry that involves the research. And that's what happened. You find a couple of growers who are representative of the industry, but also might have a say within the funding party, and they're the ones that push it through with you, so that you've got a partner on side, and that kind of helps remove some of that this is a university that don't know anything about it. And now, once we started getting funding, within the space of about 5 years, we were leading the world when it came to agriculture robotics. So it was a quick turnaround in that process. But they're the kind of mechanisms you need to go through.
So you're leading the world in this?
The work that we did was you had a couple of robotics groups doing agriculture robotics in the US, and one or two in Europe as well. But they ended up being commercial entities. And then we kind of approach it slightly different. Instead of kind of, as you would expect that you'd like to see in a university, well, what are the novel technologies that would fast track robotics into the hands of the farmer? So we focused on some key technology elements and algorithm elements that would alleviate what a farmer would do, which was different from what was going out there in industry, which was how do you miniaturize a tractor, for example, was that kind of approach. And by just kind of focusing on that, we kind of, it was leaps and bounds. We ended up getting robots onto farm and field trials all around Australia, lots of farmer days where they come in, they see the technology. We got recognised around the world. There was lots of different industry bodies around the world in the US and in the UK and Europe to give talks about the activity that we were doing. So it spread pretty quickly.
Can I just ask you about the broad area of artificial intelligence and robotics? It's fraught in many ways because there's a lack of understanding amongst the general community about what that actually means. I can remember when Malcolm Turnbull was Prime Minister and talked about an innovation economy, and everyone just thought, well, robots are going to take over my job, and it tanked as a policy because it wasn't explained particularly well. And then the flip side of that, of course, is the dual use of artificial intelligence and robotics, and then we start to venture into the foreign interference space, and we've had a lot of discussions about that. I'm just interested in your observations about how do we actually bring the community with us as a research community so they see the benefits of artificial intelligence and robotics, that A, it's not taking my job, or it might be, but there are other alternatives, and B, not everything that is used and underpinned by AI, broadly defined, can be used for nefarious purposes.
It's always been a challenge. Even when AI didn't exist, when we first started, we were doing robotics, as I said, 20 years ago, and you wouldn't be putting AI on a robot. You were just trying to automate a machine, just make a machine do a repetitive task repeatedly. And that could be something like just having a ground vehicle moving around and carrying goods from point A to point B repeatedly. But even then, the process of thinking about what a robot was doing and its relationship to jobs and the future of education and STEM, and that was always a question even 20 years ago. Probably you can, there's the areas of robotics in defence, which is an area that there's a lot of discussion around the ethics and the elements of AI and what that means in that context, and the human in the loop. What we call the human in the loop process. So even though a platform may be able to do something, or a robotic platform may be able to do something in that context, you must always have a human there present to kind of give the final okay and the decision. That there are questions like that get raised in defence, but that also is the same thing in, for example, air traffic control and aviation, and work that we did around optimization. So, yes, an algorithm is great that it can optimize how aircraft should fly, but you still want some sort of human relationship there that kind of gives the final go ahead. But as you start to kind of branch out a little bit more into AI, there's kind of this specific AI, what we probably would call in terms of specific AI and general AI. So specific AI is machine learning algorithms that sit there and show some level of intelligence, but on a very, very specific task. Such as pattern recognition. And if you need to do that a million times over, it's much easier for a platform or a robot to do it, versus general AI, which is the ability to kind of think and abstract and hypothesize like a human, which we're very, very far away from at the moment. So those discussions still happen. Do you think
we'll ever get there?
I think I've learned never to say no, but I don't. It's still a bit hard to kind of see how that would work given the current limitations, but it's one of those things where it's just hard to say no, I think.
Yeah, as we've heard, you're doing remarkable research in terms of food production, fertility of soil, efficiency of a farm, etc., all of that. But the other string to your bow is this work that you've been doing in robotics, space robotics and terrestrial exploration. Talk us through some of that.
Yeah, I mean, Australia's never had a space agency up until a couple of years ago, and so, but we've always had there's always, whenever you have students who come through the undergraduate program, space robotics is always something that captures the imagination and the interest. So we've always had a program around building rovers, and it's always been on an undergraduate and in a PhD type of scenario, where students got to build robots. We've had a number of our PhDs now. Students go overseas. They work for NASA. They work for ESA and JAXA, which has been great. It's been an opportunity to kind of demonstrate that the robotics capability, even if we never had a space industry or space agency, we were able to still contribute to the space community generally. And it was always a focus on how can you build, very similar to what we've just been talking about, how do you build greater intelligence into space rovers so that they can actually undertake more of the mission autonomously and less human intervention, and that would reduce space costs and so forth. So that gave me everything from building robots, putting sensors on robots, and building what we would call both exploration algorithms and the software. So a robot's ability to kind of sit there and go, I've sensed something here in this environment, and I believe I need to go over into this particular area over there to kind of get some more information without the human intervention. And recently we got some funding from the Australian Space Agency, once formed, to demonstrate some of those algorithms on a platform. And we were on our advisory board, we had NASA's JPL, and they were helping us with understanding mission requirements and opportunities like that. And in fact, next week I'll be heading out over there to kind of talk a lot more about the results and the outcomes from that, because it's something that all space agencies now are seeing as an opportunity of reducing mission cost and reducing mission risk by increasing autonomy on space rovers. And so that's some of the R&D work that we're doing at the moment now.
So how do we rate in Australia in terms of research in robotics and intelligent systems more generally on an international scale?
We're, if not at the top, we're definitely on par with a number of the great American institutions, US institutions in this space. It's interesting because you travel the world and you give presentations to a lot of these big industry partners around the world, get both government and industry partners, and the recognition of not just the research that we do, but the fact that we've translated that research, that we have autonomous mine sites operating, that we have autonomous cargo terminals, that we've optimized everything from supply chain optimization in mining and in aviation as examples, and also in agricultural robotics. So the fact that we're a country that is small population, relatively speaking, but it's very significant primary industry as well as logistics supply chain, has meant that both industry and academia has kind of come to the forefront of developing novel research as well as translating that into industry. And I think that's put us at the leading edge internationally.
And does that mean that universities like Sydney become a go-to institution for young scientists wanting to get into robotics?
Yeah, I think there's probably other dimensions now, as you know, with the rising costs and visas and whatever might be, it's making it a little bit harder. But internally, but within Australia, yes, it put us in a position where the Australian Centre for Field Robotics is an example, which is the institute within the University of Sydney, grew from 3 PhD students to now over 120, 130
Wow.
That's amazing.
researchers working within the centre. So
in what period of time was that growth?
That would have been over the 20 years.
Wow.
But it ebbs and flows, and as you get different industry partners coming through, which works with the economy. So so I think part of our, and maybe going full circle back to how you kind of work with industry, part of our strength has been to kind of have a portfolio relationship across different industries with different industry partners, which means you kind of, the spikes in the economy kind of get smoothed out a little bit, and keeps the industry engagement going.
So what other industries are untapped sort of opportunity? You've talked about mining, we've talked about aviation, we've talked about agriculture. What's the sort of next one off the rank, do you think?
We've just received an ARC Industry Transformation Research Hub on asset management. So we've got some depleting old assets all around the country, and one of the areas that...
Do you mean literally like buildings and things?
Physical assets, yeah. So everything from pipes and...
Old power lines, that sort of
gas,
stuff.
Okay.
Exactly right.
Yeah.
Exactly right. And so how do you use robotics and autonomous systems to support both the monitoring and maintenance of those assets and extend the life of those assets? So that's a key area going forward. We kind of define maybe there's an area called field robotics, which is outdoor robotics that have to work in 24 hours, 7 days a week, all weather conditions. So areas of around environmental management, firefighting, search and rescue. Those kinds of areas are areas that we think have got opportunity, as well as space, right? So really extreme environments. But even though we've said we've tapped into mining and aviation, that's not, there's a whole bunch of initiatives going through, like for example net zero and what that means, and then that starts to open up a whole new area of robotics and autonomous systems in those same industries as well, going forward. And outside of field robotics, there's medical robotics, which is an area that we believe is and rehabilitation robotics, which we think is an area that will be quite significant, both for growing an aging population and what that means.
So I know we're butting up against time, but I'm just really interested on sort of these expanding areas. Do we have enough young kids, our own sovereign capability in a way, and you touched on the visa issues, but do we have enough young people enthusiastic enough to actually start their careers and go to university and study to go into these fields?
Yeah, I mean, we've seen a growth in, our undergraduate degree program is called Mechatronics Engineering, and we've seen a growth year on year and it keeps growing. So there's a lot of interest in there. I've done a lot of STEM robotics work, and I can also say that there's probably a lot more we can do, especially at that interface between high schools and universities, to kind of encourage that a little bit more. And I think diversity there is important. But yes, we are seeing an increase. I mean, obviously it's a interesting area. Everyone likes to kind of work in this space or be part of this space. But I think as a mechanism, there's still, we still need to kind of focus a little bit more on that STEM process and STEM engagement with the younger generation to keep that coming through. And obviously the whole situation over COVID over the last few years, which has changed the industry dynamics around tech engineers and people with technology expertise, has also shown that there's a bright future for those. And so we're seeing that increase as well happening within the undergraduate program.
Well, Professor, it's remarkable work. Good luck for the future, and thanks for speaking with us today. And good luck with those cows and Swagbot out in the paddocks of Australia. Thank you for your time.
Thank you both, and thank you for the opportunity. Thank you.
Thanks for your company today. If you'd like more information about the issues raised in this podcast or other related topics, please visit our website at go8.edu.au. And a quick reminder that you can always tune in to Debate at Go8 on Spotify, Google, Apple or YouTube. Bye for now.